Okay, we're going to be looking at problem number 40 on page 507 from chapter 9. This one's going to be about determining a sample size that is necessary to get a confidence interval of a certain width. So when we start off on this one, the first thing it mentions is that it's talking about a settlement that Heinz had to do with the state of California, where they had to increase the amount of ketchup they were doing in bottles. Because they've been underfilling, so they promised to overfill for a certain period of time. So, and then it says that when we did a pilot study, we found that the amount of ketchup varies from 19.9 to 20.3. So when it varies from 19.9 to 20.3, we can start by figuring out the middle of that distribution, which is the halfway point of 20.1. So that is the center of the distribution. And if most of it went from 19.9 to 20.3, that means your distribution is going to look a little bit like this. Now, since it's a small pilot study, it's basically being used to estimate the mean and standard deviation. So it's estimating our mean at 20.1, and it's estimating our standard deviation at about varying from there to there. Now, this is probably the typical range, the middle 95% range. So basically I'm talking about 2 standard deviations above the mean and 2 standard deviations below the mean. So that means the distance, the total range from 20.3 to 19.9 of 0.4, that's just the distance between 19.9 to 20.3, should be equal to 4 standard deviations. So a single standard deviation is going to end up being 0.1. So that is the information that you gain from that pilot study that will be very useful when it's time to do your confidence interval. Now, the confidence interval formula that I would be using would be the statistic plus or minus the standard deviation of the statistic. In this case, since I'm dealing with means and I know sigma, it would be z star times, the critical value would be z star, and then the standard deviation of the statistic would be sigma over square root of n. And I'm basically using the standard deviation from my pilot study as my sigma value. And if I'm trying to get the answer, I need to find out what level of confidence I want. I'm looking at a 95% confidence interval, so that means I'm going to have 95% of my data in the center of my distribution and only 0.05 in the 0.025 in the tails. You could look this up on your table, or I'm going to show you one more time how to do it with the calculator. With the calculator, you would do second distribution. Since we're talking about a z critical value, it would be inverse normal. The area in the tail would be 0.025. Since it's standard normal, leave 0 and 1 as your mean and standard deviation. That gives you a value of negative 1.96, which is the same thing it'll tell you on your table. So this critical value, my critical z value, is basically plus or minus 1.96. And once again, they usually just write that with the positive since the plus or minus. Now, it does not require you, in this case, to even use your x bar, because what I'm concerned about is my margin of error. And my margin of error is the part of the formula that comes after the plus or minus. So that's the part that is my margin of error. And it says it wants me to get it within 0.01. So that basically is telling me my margin of error of 0.1 is going to be equal to this part of my formula up here. So I'm going to go ahead and substitute into that part of my confidence interval formula. My critical value, I just found out, my z star is 1.96. Like we said, we're estimating standard deviation as 0.1. And what we're solving for is the square root of sample size. Now, I would initially multiply both sides by radical n. So I'll go ahead and solve this in blue. If I multiply by root n, it'll just cancel on this side, and I'll add a root n to this side of the equation. And I'm going to go ahead and simplify, so I have 0.1 root n equals 0.196. Now I'm going to divide by off the 0.01 from both sides, so that's going to give me root n equals 1.96. And then to finish your problem, you just have to remove the square root by squaring both sides. So this is going to give us a very small sample size of 3.84. Now this is saying n has to be at least 3.84 to make my margin of error no more than 0.1. So I'm going to round that up to a sample size of at least 4 units. Even if that would have been something like, for example, if I would have gotten an n value of 4.01, I would have had to round that up to 5, because if I'm required to have at least 4.01, it would go up to 5, just like if something costs, $4 and a few cents at a store, they would prefer you to go ahead and hand them a $5 bill as expecting them to make up the difference. So that should show you how to get sample size. In this case, a very small sample was sufficient to get the margin of error that you needed.